The topic pipes and cistern and time and work are similar in nature. I have already given a video of time and work, the link you can find in description. In this video, I am emphasizing on must-do question types in pipes and cistern topic. So watch the video till the end to know all the question types. Don't forget to subscribe to the channel. Let's start.
So let's go to the first type of question in pipes and cistern. So in this question it is given two pipes A and B can fill a cistern in 20 and 30 minutes respectively, and the third pipe C can empty it in 40 minutes. So how long will it take to fill the cistern if all the three pipes are opened at the same time? So the question of pipes and cisterns should also be done in the same way the questions of time and work has been done. So the approach has to be same. Okay, so here I am writing the pipe A can fill it in 20 minutes, so I am writing here time to fill in minutes, and for B can fill in 30 minutes, but C can empty in 40 minutes, right? And we should assume the total capacity of the tank as the LCM of the individual minutes. So capacity of the tank should be assumed as the LCM of 20, 30 and 40, which should be 120. So 120 liters say is the total capacity of the tank. And now the same way we used to write the work per day in time and work questions, here we should write liter per minute for A and B, which are the inlet pipe. That means liter per minute filled by A or B, but in the same way we will be writing liter per minute emptied by the pipe C, right? So liter per minute by A is 120 by 20, that is 6 liter per minute it is filling. Pipe B is filling 120 by 30, that means 4 liter per minute, and pipe C is emptying it 120 by 40, that means 3 liter per minute it is emptying. So I am just putting a negative sign, right? So if all the three are open, that means the inlet pipe A and B and the outlet pipe C, if both are open, so they will be filling per minute 6 plus 4 minus 3, that is 7. So 7 liter per minute effectively will be filled when all the pipes are open together. So how much time it will take to fill the whole tank, which has a capacity of 120 liters? So 120 divided by 7, so it will come out to be 17 1 by 7 minute. So C is the answer. Let's go to another type of a question. The question says a pump can fill a tank in 2 hours, but due to leak it took 1 by 3 hours to fill the tank. The leak can empty the tank in. So we will proceed in the same way as we done in the last question, right? So there is an inlet pipe A and there is an outlet pipe say B, and when we are combining, then we are again the tank is being filled in some time. So here I am writing time in which the tank is being filled. So by the inlet alone it can be filled in 2 hours, but due to a leak, that means when you are opening both the pipes, inlet and outlet, then it takes 1 by 3, that means 7 by 3 hours to fill. So here we have to write the rate of filling or being emptied, that means a liter per hour. So for this you have to assume the capacity of the tank, that is the LCM of 7 by 3, just to in order to avoid the fraction. So I can take LCM or any multiple of LCM, so I can take 28, so just like take 28 as the capacity of the tank. So in this case you will get A, the rate liter per hour filled by A, that is 28 by 2 means 14 liter per hour, this is filling. And both combined, I mean when this inlet and outlet both are combined, so they are filling effectively 28 divided by 7 by 3 that means 12, right? So from this you can find out what is this b is emptying how much, because a is filling 14. B is, when B is emptying minus 2 liters per hour, then only you will get A plus B is equal to 12, right? So this question, the leak can empty the tank in. So time for the leak to empty the tank will be the capacity of the tank, which is 28, divided by the rate at which it is emptying, which is 2, comes out to be 2, divided by 2, you will get 14 hour. So 14 hour is the answer, option D. So here we have another question. Two pipes A and B can fill a cistern in 12 minutes and 15 minutes respectively, while a third pipe C can empty it in 6 minutes. Pipe A and pipe B are kept open for 5 minutes in the beginning, and then pipe C is also opened. In what time the cistern will be emptied? So A can fill in 12 minutes, B can fill in 15 minutes. So I'm just writing time, individual times to fill, and C can empty in 6 minutes, right? So I'm just writing minus 6. Okay, so first thing what you have to do is to find out the capacity of the tank, which you can assume by taking LCM of 12, 15 and 6. It will reduce the calculation, that's why we are doing it. So this comes out to be 60. So we have assumed 60 liter is the capacity of the tank. So now the next thing what we will do is to calculate the rate, that means liter per minute. Here liter per minute it is being filled or being emptied. So in case of A, 60 by 12, that means 5 liter per minute. In case of B, 60 by 15, that means 4 liter per minute. And in case of C, this is 60 by 6, that means 10 liter, which is minus. Okay, that means 10 liter per minute it is emptying. Right, so now in the question it is given pipe A and B are kept open. So when you are opening A plus B together, you are getting 5 plus 4, that means 9 liter per minute filled for 5 minutes. So in 5 minutes with the rate of 9 liter per minute, 9 into 5, that means 45 liter will be filled. Okay, and then C is opened. So what is happening, you can see 45 liter is filled, and when you are opening C as well, so I can write A plus B plus C. So if you check A plus B plus C, so 5 plus 4 minus 10, 5 plus 4 minus 10, that is minus 1. So when you are opening all the three pipes, it is emptying 1 liter per minute, and in 5 minutes 45 liter has been filled. So how much time it will take to empty, because the result now it will be emptying the tank, right? So 45 liter divided by the rate with which it is emptying, which is 1, so it will take 45 minutes. So this is the answer, that means option D. So let's take the next question. In this question it is said two pipes A and B can fill a tank in 36 minutes and 45 minutes respectively. Pipe C can empty the full tank in 30 minutes. Pipe A and B are opened, and after 7 minutes pipe C is also opened. So in how much time the tank will be full? Okay, so A can fill it in 36 minutes. Here I am writing time in minute, and B in 45 minutes. Pipe C can empty in 30 minutes. Okay, so first thing you have to do is to find out the rate at which it is being filled, that means liter per minute. Okay, and for this you should assume the capacity of the tank has the LCM of 36, 45 and 30, right? So that will be the multiple of 45, which comes out to be 180. The LCM is 180, so I am assuming 180 liter is the capacity of the tank. So A is filling 180 by 36, that means 5 liter per minute, right? B is filling 180 by 45, that means 4 liter per minute, and C is emptying 180 by 30, that means 6 liter per minute. I am putting the minus sign because it is emptying the tank. Right, now what is said, A and B are opened. So when you are opening A plus B, they will be filling 5 plus 4, that means 9 liter per minute. And after 7 minutes, so in 7 minutes, you can see in 7 minutes A and B, which are filling 9 liters, so 9 multiplied by 7, that means 63 liter they have filled in 7 minutes. Okay, so how much is left, or the remaining capacity? So remaining capacity which is left is 180, that is full capacity, minus 63, so that will come out to be 117 liter. And for this, pipe C is also opened. So when you are opening pipe C, that means A plus B plus C, the rate at which they will be filling it, 5 plus 4, 5, I'm just writing 5 plus 4 minus 6, okay, that will give 3, right? So that means when you are opening A, B and C, C is an emptying is an outlet pipe, so effectively 3 liter per minute is being filled, and the remaining capacity which is left is 117 liter. So time it will take is 117 divided by 3, that will be equal to 39 minute, right? The question is in how much time the tank will be full. Okay, so 39 minutes. So total time you can write, total time it is taking is 39 minutes plus 7 minutes it has already taken, plus 7, so that will be 46 minutes. So 46 minutes is the total time. Option A is correct. Let's take the next question. Two pipes A and B can fill a tank in 6 hours and 4 hours respectively if they are opened on alternate hours. And if pipe A is opened first, in how many hours the tank will be filled? So A is taking 6 hours, B is taking 4 hours. Here I am writing time. And if they are opened on alternate hours, so first thing we have to find out the rate at which it is being filled. So total capacity should be taken as the LCM of 6 and 4, which is 12. So 12 liter is the total capacity, and as per this assumption we are getting A, the rate of A is 12 by 6, which is 2, rate of B is 12 by 4, which is 3. So what is happening here, if they are opened on alternate hours, right, you're starting with A, so that means A and then B, in this way they are being opened. So A is filling 2, then B is filling 3, and again A is filling 2 and B is filling 3. So 2 plus 3, that means if 5 liter is filled in 2 hours, and this next 5 liter is again filled in 2 hours. So 10 liter is filled. After that 2 liter is left, so that will be filled by A alone in this 2 liter in 1 hour, because A is filling 2 liter per hour, right? So 2 hour plus 1 hour, that is 5 hour will be the total time. The same has been asked, so answer is C. Let's go to the next question. In this question it is said two pipes A and B together can fill a cistern in 4 hours. Had they been opened separately, the pipe B would have taken 6 hours more than pipe A to fill the cistern. Pipe A can fill the cistern separately in, so it is given here A plus B, if both are opened they can fill in 4 hours. I am writing here time in hours. Okay, and for A and B it is not known, but this is given that B would have taken 6 hours more. So if A is taking say X hour, B would have taken X plus 6. So in this case we can directly find out, the time taken by both of them together when they are open together. Then A plus B can take, time taken by A plus B can be written as x multiplied by x plus 6 divided by x plus 6. Right, in case you have imagined the total capacity, then also you would have got the same formula. Or in fact, this is the formula when two inlet pipes individual timings are given, then you can use this. In either ways you are getting this, and this is equal to 4 hours. Now what you can do, since this is an objective type question, you can put here different options to check which one is correct. So with 1 can you get 4? So no. With 2 can you get 4? 2 into 16 plus no. With 6 can you get? So yes, 6 multiplied by 12 divided by 18, that is 4. So with C option is only able to fit the value of this, right? So that means option C is correct, and the value of x is equal to 6. So let's take another question. Two pipes can fill a cistern in 14 hours and 16 hours respectively. The pipes are opened simultaneously, and it is found that due to a leakage in the bottom, it took 32 minutes more to fill the cistern. In what time will the leakage empty the full cistern? So we will proceed in the same manner, in the same approach. So A is taking 14 hours. I am writing here the time in hours, and B is taking 16 hours. Okay, the first thing that we have to do is to find out the capacity of the tank, which should be the LCM of 14, 16. So that will be 56 into 2, which is 112. Okay, so 112 liter is the capacity of the tank, and accordingly we will find the rate at which it is being filled. That means liter per hour. Okay, so A is filling 8 liter per hour, B is filling 7 liter per hour, and the pipe are open simultaneously. We found that due to a leakage, the bottom, it took 32 minutes more, right? So the time taken by A and B, if there was no leakage, so in that case the time would have been 112 divided by 15, 8 plus 7, that is 15, this much minute, so this much hour rather, so we have to multiply this by 60, so I will get in minutes. 112 multiplied by 4, which is 448, so 448 minutes they would have taken if there was no leakage. So now because of leakage that it is taking 32 minutes extra. So 448 plus 32 minutes extra, which comes out to be 480 minutes, right? So 480 minutes, or we can say 8 hours. 8 hours it is taking, right? So rate at which it is filling, so rate at which it is filling is 112, because this is the capacity of the tank, divided by filling in 8 hours. So this comes out to be 14 liter per hour. So this is the rate at which it is being filled with the leak. So I can write here A plus B plus C, which is a leak, and this rate is comes out to be how much? 14. So from this you can find out what should be the rate of leak. So 8 plus 7, that means 15. So C must be equal to 1, that means minus 1. So that means the leak is basically emptying the tank with a rate of 1 liter per hour. So the question is, in what time will the leak empty the full cistern? So time taken by the leak to empty the full cistern is having 112 liter capacity, and leak is emptying it with the rate of 1 liter. So just divide 112 by 1 and you will get 112 hours. That should be the answer. Option D is correct. So here we have another question. Two pipes A and B can fill a tank in 60 minutes and 40 minutes respectively. How many minutes will it take to fill the tank from empty state if pipe B is used for half the time and pipe A and B fill it together for other half. So we have to keep this in mind. We will approach in the same manner. Two pipes A and B, they are taking 60 and 40 minutes. I'm just writing time. Okay, so first thing what we have to do is to assume the total capacity of the tank. So total capacity should be assumed as the LCM of 60 and 40. This will reduce the calculation. So this has to be 120 liter. Okay, here I am writing rate, that means liter per minute it is being filled. So for pipe A, it is the rate is 120 by 60, that means 2 liter per minute. For pipe B, 120 by 40, that means 3 liter per minute. Now what is being said, how many minutes will it take to fill the tank from empty state if pipe B is used for half the time and pipe A and B together they are used for other half? So you can think like if total time I am assuming 2t is being used, right? So A is this B is used for half the time, and A plus B, so A plus B if they combine they will fill 3 plus 2, that means 5 liter per minute they are used for the other half, and the total time is 2t. So we can just write that when B is used for time t, so B is filling this 3 liter per minute multiplied by time t plus A plus B, which is filling 5 liter per minute multiplied by time t. This is equal to the total capacity because they are filling the whole tank, which is of 120 liter that we have assumed. So from this you can calculate directly T is equal to 120 divided by 5 plus 3, that means 8. So 15, T is equal to 15, and the total time we have assumed 2T. So that will be 15 into 2, that means 30 minutes. Okay, so 30 minutes is the answer. Option D is correct. So here we have another question where the efficiency of 3 different pipes are also given. So a tank is filled in 5 hours by 3 pipes A, B and C. The pipe C is twice as fast as B and B is twice as fast as A. How much time will pipe A alone take to fill the tank? So we will approach in the same way like A, B and C, but since here efficiencies are given, so we can directly write their rate, that means liter per hour they are filling. This is in the same way in case of time and work question we used to write work per day. So the same analogy is being used. So as per the question it is given A is B is twice as fast as A. So if A is doing filling 1 liter per hour, so B has to be twice 2 and C has to be twice of A. C is twice as fast as B, so C has to be 4, right? So this we have got as per this information. Now it is said that the tank is filled in 5 hours by all three. So that means if we combine A plus B plus C, we will get 4 plus 2 plus 1, that means 7, and it is filled in 5 hours. So with this the capacity has to be 7 into 5, that means 35 liter. So 35 liter is the capacity, and the question is how much time will pipe A alone take to fill the tank. So pipe A is filling 1 liter per hour, so time taken by pipe A will be 35 by 1, that means 35 hour. Okay, so answer C. So here we have another question based on efficiency. A pipe can fill a tank 3 times as fast as the other pipe. If together the two pipes can fill the tank in 36 minutes, then the slower pipe alone can fill the tank in. So we will approach in the same manner. A and B, two pipes are there, and it is given that the name is not given, but I have just assumed one pipe is 3 times as fast. So if B is say 1, A is 3, so I'm just comparing their efficiency. That means rate at which they can fill, it is in liter per minute that we can assume. Okay, so if B is 1, A is 3, the faster one. Now combining these two, A plus B can fill 3 plus 1, that is 4 liter per minute, and together two pipes can fill tank in 36 minutes. So together they are filling 4 liter per minute and the tank is filled in 36 minutes. So from this you will get the total capacity is equal to 36 into 4, that means 144 liter, right? And the question is the slower pipe. The slower pipe is this one, the pipe B, which is filling just 1 liter per minute. So it will take 144 total capacity divided by its rate liter per minute, that means 1, which comes out to be 144 minute. So it will take 144 minute to fill 144 liter. So the answer is option C. So here we have covered a different type of question in pipes and cistern. I hope this helps.